Whether you're a machinist or a framer, sometimes you've just got to drill a hole dead center. We did a video on that, I guess a couple months ago now, and we got a lot of it right and we got some of it wrong, and we've learned some more things from the comments that I wish I would have known, including this little gizmo. Been around a long time, we're going to tell you what that is, including this little gizmo, which nobody mentioned but I found online, which is next level 21st century magic. But in general, if you've just got to get it right, if you're interested in some more things that probably should be in your toolbox, stick around. Here's some new ideas. First thing that I got wrong is that when it comes to getting a center punch, even a prick punch or a spring punch or any of the rest into your mark, your sense of touch is more accurate than your eyes. Like this, I hope. So you put your scratch awl in there and you scratch a real mark. You scratch it. Now we're going to scratch it the other way. Imagining that that is precisely in the location it needs to be. So that's a pretty good mark. Now in theory, I can feel this punch drop into that intersection. Yep. I can feel it drag and hang up in that intersection, ostensibly more accurately than just looking. Let's see. Oh yeah. Better than I did on the last video. So this is a prick punch, I learned. I had one in stock. I had to resharpen it. It's a long gradual taper and a fairly gradual taper at the very end compared to a more conventional cold punch. It's easier to see around that, and it's easier to feel when it drops into the mark. But don't hit it very hard or you'll bend the whole thing. Now the last video was done entirely drilling by hand. And so I'm going to put a little pilot hole here by hand, but one of the comments was, and I knew this but didn't mention it, is that when you start to drill, you can kind of correct. You can encourage that thing to wander if you need it to. Now I'm not going to need it to in that particular hole because that is well located. But a light touch, you don't push very hard, you're just creating an indelible reference, right? So be a little gentle. And if you want to load that bit a little bit, push it a little, it will still wander a little right or left. You can do this, you can do that. So you have a few moments when you begin to put the bit on the steel that you can make it better if you need to. Now I've been learning a lot about this since that last video. And one of the things that I learned is that the angle of the grind makes a big difference. This is sort of a standard. The ordinary bit that you get, just a twist drill for metal work or machine work, is, I think, 118 degrees. They make a flatter grind. This is called a screw machine bit. It's very short and double-ended, so you can chuck that up and have very little bit out there bending around. This is, I think, 135 degrees. It's stronger, it's bulkier, and it's harder to get centered perfectly. They also make, I couldn't find to buy today, a 90-degree bit, which is sharper yet. In much the same way that this prick punch comes to an easier to recognize point, a 90-degree grind would be easier to see as it makes contact with the dead center spot. So pretty much everything I just said pertains to drilling steel, metals, right? But a lot of us drill wood, including me. So let me show you just one or two bits and one or two things that are probably intuitive, and I'm not sure if I mentioned it. And the first one is something that I've learned from the comments about how to tighten up the chuck on a cordless drill. A keyless chuck, you tear the skin off your hands. I learned that there's a backwards rotation. Click. Somehow that little click locks a much tighter grip on the screw than you can get just by fighting friction with your hands. I don't get it. But this is a type of a Forstner bit, I guess, and it has that little brad point, which is so handy for coming to any sort of an exact location, much like what we just did on steel. And you start out slow. There is your point. stopping before you drill into your bench. The comment also came through, you stop before you go out the other side and then drill in from the back side. Yes, to minimize blowout. Or you clamp it down on a backer, not your bench, so that it doesn't blow out. All of those things come over time, but the concept is the same no matter what wood you're drilling or what kind of bit. It will blow out on the bottom. All right, to the exciting stuff, new tools. Optical punch. I had never heard of it until the comments enlightened me. You see that? This is some sort of a little optical prism that has a crosshair built into it. I mean, like your rifle scope, and this is a center punch, and they have the same diameter. So you can put your scope on there, run it down, run it out over your work, look down through there like a jeweler, center it up precisely over the intersection, pull it out, drop the punch in, and pow. That, my friends, is a nice punch. All of you guys that mentioned this, thank you, thank you. Now let me return the favor. So check this thing out. I was online looking to buy one of those optical centering punches, and this popped up. I mean, they're good at that, right? A bullseye bore, and I thought, what the heck? And I clicked on it, and it is the coolest thing. And I paid for it. I pay for most of my tools. Sometimes people send me stuff. But if you're the kind of guy that does not appreciate sponsorships, but are interested in supporting something that you get some good out of, if you get some good out of this channel, the best way to sponsor what we do is to join the Essential Craftsman Academy, because it's a value trade. I mean, you send the monthly subscription and you get a ton of additional content and shop talk. You can ask me questions and the other guys there assembled, but check that out if you want to help the channel. But this thing, you slide that on there, you make sure you've turned it on. Yes, it's centered. And if you've got a drill square in both axes, it'll tell you. Look at that. See that? If they're concentric and round, you're square. If they're oblong and not concentric, you're not square. So you just keep them concentric and you go forward. And that solves a problem that's been plaguing carpenters for a long, long time. Okay, here is an oddball twist drill, but different, with a carbide tip. They have silver soldered, or however you attach stellite or other cutting surfaces, a carbide tip and a drill bit. And it will cut anything for hard metal, including stainless, granite, tile, marble, meets ANSI standards. And I'll tell you what, they told me at the store, don't lubricate that. Let it run dry. Don't put too much pressure. Don't turn it too fast. But that thing, my friends, will put a hole through almost anything there is. The other oddball is a left-hand twist. That's a left-hand drill bit. Only cuts going backwards. That's for drilling out the bolts that you break off. You've broken off bolts. You got to drill them anyhow to get an easy out in there. Drill it out with a left-hand twist drill bit, and it might just hang up and back that bolt out before you even have to break loose your easy out set, if you could find it. So you've seen me use this Arboga Maskiner radial drill in my blacksmith shop before. I bought it 15 years ago. It's from the 1970s. And I don't even know if I was going to buy something like this new. I know it would be $100,000 or maybe more. And this gigantic vise, which is off an old shaper, I don't know how I would duplicate any of this. But I know it would cost money. But if you need some of this capacity of drilling in a drill press, very close tolerance, without having to break your arm every time you drill the hole, let me show you a way to modify a smaller drill press to get a lot of the good out of it that I get with this. Okay, so in that last video that we were just talking about, one of the things I didn't mention that I should have is the utility of transfer punches. I got a set of transfer punches, and what they are is a punch of specific diameters with the center punch ready to rock. I'm going to use it to mark the last fourth hole that I had to drill and tap into this magnetic chuck in order to attach this little Wilton vise, like this. I was getting ready to drill right there, but it's too close to that penetration. So, not wanting to scratch the center line, I'm going to move this over. It's the same diameter as that slot, so I know I'm centered. I'm going to come over about there and just go pink. And there we have a nice little mark that I'll drill later off camera and tap. All right, so I'm going to drill a nice square, I don't know what that is, 5/16 hole. Put that block in there so when I lay the piece of steel in, I know that it's parallel to the table. Block's a little smaller than the steel. And now the challenge becomes, how do you hold this still to line it up under there and keep it still as you're drilling? Or if you've got several holes, you've got to duplicate, you've got to jig up. Man, look what Marius Hornberger, is that what his name was? Look what he showed me. A magnetic chuck. Look at that, my friends. You can see how easy that is to move. And then the other thing, down here on the floor, is a foot switch that Ken Jordan gave me. And so I don't have to take my hands off the work. I can bring it into contact, hit go with the foot, go right on through. Now just a note about lubrication. Not all oils are created equal. I've become a convert to rapid tap cutting fluid. If you guys know a better brand or one is good, let us know, would you? Look at that. Both flutes are cutting. That means they're ground evenly. I'm not going to stop to re-oil that. We're just going to keep going. And presto. Look at that. Now you want to take it over to the other bench. You're unhooked just like that. Let's say that we want to run that precise hole, that we want to mark that hole onto another piece of work. Your transfer punch of the right size drops in and bam, bam, bam. There it is. You can visualize a lot of ways to use that. So maybe the biggest thing I've learned about drilling holes since I put up that last video is that the technology and the specifics and the information around the simple process of drilling in steel is a limitless, endless rabbit hole. There is so much information about feed rates and speed rates and high-speed steel and cobalt and carbide and carbon steel and brass and stainless steel. Stainless steel is the monster. There's so much to know. And some of you know every bit of it, and I don't know much of it. But please put in the comments the things that we have forgotten yet, the things that maybe just any do-it-yourselfer ought to know before he tries to put a hole in exactly the right spot. Thanks for watching Essential Craftsman, and keep up the good work.